Now in this question, they're looking for you to find the intersection of two lines. More specifically, once you find that point of intersection, they want you to do the x-coordinate minus the y-coordinate. Now for us to be able to find the point of intersection, we first obviously need to graph these two lines. And notice in the case of this first line, they give you the slope and a point. So that should sound familiar when you hear slope, point, or point slope. Let's go ahead to one of our programs. Remember, some of them are functional, like they actually do something, whereas others are more informational. And we're gonna go to one of the informational programs called function. And notice you have three different kinds of functions. We're gonna choose linear. And within that, we have three different kinds of equations for a line. We have slope intercept, standard, and point slope. So the fact that we have a point and a slope means we're gonna wanna put it in this point slope form, which is y minus y1 equals m times the quantity x minus x1. So we know the slope is 4. That's an easy one to plug in. The x and the y that don't have the subscripts are literally just rewritten as x and y in this form. Now, when you see minus, that really just means the opposite of. In this case, when we say minus y1, we're saying the opposite of the y coordinate. So the opposite of -5 is +5. And then same thing here, the opposite of the x coordinate, so the opposite of the +1 is -1. Just be sure that you put the y coordinate here and the x here. A lot of times people will switch those. So now we have one equation in point slope form. We could get it into slope intercept form, but I would like to avoid making mistakes whenever possible. So distributing and then moving this over gives us more chances to make mistakes. And then for the second line, they say it goes through these 2 points. Now there's a couple ways you could find the equation of that line. However, to me, the easiest way is going to be using our program slope in. So let's go to that program number 3, and then we'll just type in these two ordered pairs. So 0, 4, and 12, 0. And that gives us the equation of the line in slope intercept form. Notice they're saying -1/3 is the slope, 4 is the y-intercept. So we have -1/3 x plus 4. So now we have the two equations that we need. And we could go ahead and graph them, and we could choose to do it on our graphing calculator. However, for our graphing calculator, we need it in slope-intercept form. And this one's in slope-intercept form, but this one is not. So in this case, I would actually go to Desmos, which is in the upper right corner here, just as it is in the actual software that you're using for the SAT. And I'm keeping these two equations on my screen. They'd be in your scrap paper, of course, but we're gonna go ahead and type these in. And notice this one, I could just type in as is. I'll just do -1. I'll do my fraction bar, which is the /. You could also choose to use their keyboard here if you prefer, totally up to you. And then we're gonna do x plus 4, enter. And for the second equation, I'm gonna type in this whole thing, y plus 5 equals 4 times the quantity x minus 1. So now we're gonna go to the point of intersection, which is right here. And then once we find it, the x and the y coordinates are actually the same, 3 and 3. So they're looking for a minus b for that point. In other words, they want 3 minus 3, which makes the correct answer C.